Hi, I didn't see you there. My name is Heratio VonStinkenberg. Today we'll be talking about probability, starting with fundamental counting principle. The formula for fundamental counting principle is m times n, where m is the number of things you are timesing, as well as n. I'll give you an example. In our explanation, we'll be doing a sandwich. We have 4 different types of condiments, 2 different types of bread. Our bread choices today are thawed multigrain bread and frozen multigrain bread, and 3 types of cheese. Our cheeses today are shredded Montgomery Jack cheese, string cheese, and medium cheddar cheese. What you need to figure out is how many different sandwiches can you make. Up to the board. We will be starting out with the condiments. So that's a simple 4 times the bread, 2 times the cheeses, 3. Which one of these answers is correct? You're right, it's E. 24. Good job. It's been nice speaking to you, but I must go. Today we have found a volunteer to try the least favorited combination of sandwich. This combination includes frozen multigrain bread, Worcestershire sauce, and shredded Montgomery Jack cheese. Let us give a closer look.
This is so hard to chew.
This is a brave man.
Hello, my name is Augustst Vonstinkenberg. You may have met my brother, Heratio. Today we'll be talking to you about permutation and combination. Permutation can be represented from R and N. Permutation is when you have a group and then you're going to form a subgroup and arrange that subgroup. So, a good example of that would be when you have 30 members in a club. You want to pick a president, a vice president, a secretary, I don't even know how to spell that, and a historian. To choose this, the equation is going to look like this. Plug that into your calculator. You should get 6,577,200. To do this on your calculator, push math, then left, and then down 3. It should say NPR. Choose that one. And what you would do is you type in this first number as N, then you would have this in the middle, and then have 4 as R. And that should give you this big number. Permutation is used when you're arranging items in a subgroup. So it'd be like books on a shelf, you know, you have books and you want the red one here and the blue one and the green one. And that's how you arrange them, and this equation would be how you do it. Okay. Combination. Combination is very similar, but it's not. It looks like this. This could be explained by the number of subgroups of a big group that can be selected from a distinct group. what this could show you, when you have a problem like this, you would have a group of 6 and you'd be choosing 3 of them. And it's every different combination of those 6 that you could pick 3. The answer to this is A, B, or C, or maybe even D. The correct answer is not D, it's E, 20. You would type the same thing into your calculator that you did before, but you would do NCR. It would look like this. There go my papers. Look like this. This would be used if you were just choosing a group of students and it didn't matter which order. 3 students out of 6. And it'd be all the different combinations you can make. I've got to go now.
Hello, and welcome to another video. My brother Augustus tells me a lot about you. My name is Heratio. Today we will be telling you about probability and odds. Probability is
a ratio of successes to total outcomes.
Here we have the success formula. As you see, S stands for success. Success over total number of outcomes equals success over success plus failures. And failures F equals F failures over total number of outcomes equals F over S plus F. Odds is what we are going to talk about now. An event can succeed in S ways, it can fail in F ways. So, odds of success would be S compared to F, which is success compared to failure, as well as this is failures compared to success. So, what is the difference between probability and odds? Well, you see, in probability, you compare success to the total amount of outcomes. And in odds, you compare successes to the total amount of failures, or the other way around, failures to successes. What we are doing here is this. It's probability, yes. The total amount of successes over the total amount of outcomes. And converting it to odds, in order to convert it to odds, you have to compare the total amount of successes to the total amount of fails, which this would equal 31 to 6, because there are 6 failures after this. And those are your answers. It's been nice speaking to you, but I really must go. Goodbye.
Hello again. I'm going to be talking to you about multiplying probabilities. To understand multiplying probability, we have to understand there are 2 types, independent and dependent. An independent event is when the outcome of the first event does not affect the following events. What you would do is you'd roll it. I got a 4. The chances of rolling a 4 are 1 out of 6. And then the second time, we would roll, and I got a 1. Chance of rolling a 1 is 1 out of 6. On one of the rolls, we want a probability of getting an even number. I got a 2. So the chances of getting an even number would be 3 out of 6. Multiply across, which equals 1/72. The chances of rolling a 4, then a 2, then an even number is 1/72. A dependent event. This would be like choosing from a small bowl of M&Ms. There are 6 blue, 3 yellow, 6 orange, 3 red, 2 green, and 1 brown. A dependent event would occur without replacement. Replacement is as if I chose one, didn't want it, put it back. It would not change my odds of getting the same color. A dependent event would be like me choosing an M&M and then eating it. We're going to pick 3. We're going to find the probability of picking an orange, then a red. The probability of picking an orange would be 6 over the total number. The total number of M&Ms is 20. We're going to find the probability of picking 1 orange, then 1 red. So you take 6 over 20 times 3 over 19. Because we went down 1 because we had already taken out 1 M&M. So you multiply across 18 over something. I don't even know. This would be 380. I don't even know if that is simplified. Which simplified is 9 over 190. This is called a dependent event, and the previous was an independent.
So, my brother Augustus, he left off multiplying probabilities. Now I'm here to show you how to add probabilities. We start out with mutually exclusive, which are two events, or any amount of events that cannot happen at the exact same time. For instance, picking 3 green M&Ms or 2 red M&Ms. And the formula for this is P probability of A, green, or probability of B, red, M&Ms over the total amount. So here's would be the equation. There are 10 total M&Ms. So it would be 3 over 10 plus 2 over 10 equals 5 over 10, which reduces down to 1/2. And that is how you add mutually exclusive events. And now we are going to show how to add inclusive events, which are events that can happen at the exact same time. This is an example of an inclusive event. The equation is pretty much exactly like the mutually exclusive, except for you have to minus the total number of A's plus B's. 7 people eat a green M&M and 7 people eat a red M&M. One of the people eats both. So that would be 7 or 7. Yeah. The 1 over 15 is the person who ate both M&Ms. You take that out because he did both things. So what you're going to end up with is 14 over 15 minus 1 over 15 equals 13 over 15 is your correct answer. That concludes all for the day. We hope to see you next time on Gangsta Math.